to have you all. We have again put together two working groups for today because it is relevant for low trophic aquaculture topics and product developments. So the topic for today is data availability and uses. And we will be me and also Maya today hosting you. So for we are 35 people in the room, and many of us know us already. But since we had such a extravagance of new additions, I meant to stay also to say a bit about our news. Usually, for those that are coming for the first time, as it's a working group, we have it kind of unofficial. So meaning that we are presenting the Submariner news as this is an official working group meeting. And we are a network. We present our news. We move on with the discussion with the excellent speakers we have today, and then in the end we might have also opportunity for bottom-up interventions, your news, your pitches, something between. We have 2 full hours and we have a packed agenda. So yeah, for those of you that don't know us, actually now we are 13 full members and about 30 associate members. We are promoting sustainable and innovative use of marine resources in the Baltic Sea region and beyond. We are leading the mission Ocean, coordinating support action of the Baltic and North Sea Lighthouse. And also partners, one of our founding members, ESPRO, is also a member of the great consortium of EU for Algae. I would like to ask you to mute your microphones.
Mute? Thank you. Yeah.
Otherwise, we will chop. Yeah, so we are very well, we are a network, but we are also very well connected. So we are connected through our projects with all around Europe and beyond. So what I would like to, I think I would announce also here that among our projects, we have the privilege and very, very excitement to participate in the EU for Algae 2 consortium. So the new EU for Algae is coming in January, and you will hear more in the last meeting in December. We are planning on the 8th of December, so you will hear more about it. And it's available both hybrid and also in Athens. So we are EU for Algae came to stay, and we are very, very excited about it. More news soon. Yeah, we are working in the different solutions, as we call it, to deal with both regional and global environmental issues, but also looking at combining economy with environment and human. So we're working across all dimensions of sustainability, and we're working across this to find the solutions from bringing it out of the lab and into the market, across with different actions as projects. So EU for Algae is also here, and we divided them into educational and skills activities, into business development activities, into science-based policy and demonstrations. All of these are coordinated through our roadmap, so you can have a look also at Submariner roadmap. And with you, we are a program that we are developing constantly, bringing the Baltic Sea region and the North Sea now into European and global roadmap. So we would like to join our Submariner working groups. We have many. You can find them all in the blue biomats, and Maya will tell you more later. So apart from the algae working group, which was previously the macroalgae working group, and last year, in the beginning of this year in January, we made it into algae working group, meaning also microalgae working group. We have also mussels working group. We have the fish aquaculture working group, and we have also a new sustainable fisheries working group with not so many members yet, but we have already 2 meetings, and we wish you join. Similar story. And also as the algae and the mussel working group is the oldest. And we have also new women in the blue economy, which is building on the WinBig project we have. Now, you can find them all in the blue biomats, where you can meet with your fellow members into also offline. So we're meeting once in a while. We have working groups meetings, but also in the Blue Biomass, the working group discussions are keep on going. So I welcome you to join these working groups there. For today, I have a very nice panel of speakers, and we are really, really excited. So I will start with introducing Philippe from Agri-ST. You are working with you're working previously with the Algae Selfies and Nutrients, Digimare Cinea project, and now you will talk about the scaling up EU cultivation for shellfish and algae, as you have the follow-up project after the algae shellfish and nutrients. We would like very much to hear what you have, and I think you have also plans for us to, as you need also not only to give us, but also take something from us. Philippe, your floor is yours, and I will stop sharing now.
Okay, thank you. Oh, thank you very much, Talia. So yes, I will share my screen if I can. Yes, okay. Yes, is it in full screen? Is it okay?
Oh, everything is good.
Okay, yep. Thank you. So I will present you first. Thank you for the invitation of this workshop, and we will present you the project we have done and one and the other in progress in the frame of CINEA, European Commission for the Green Deal. First, I will present the consortium. It's a SME consortium of three SME, Bantry Marine Research Station from Ireland, Acteon from the east of France, and Agri-ST, us from France. So who we are? Agri-ST is an independent SME of about 150 people, mainly in the space sector, but we are strongly involved in oceanographical data analysis and production to support national and international directives for water, MFSD, WFD, OSPAR, and we are well involved in aquaculture and fishery support by satellite and model output. We are strongly involved also in operations, software and development, and we work on ocean color since 1990, both on instrumental and algorithmic aspect, data processing, and so on. And we provide OCETAC, is the ocean color technical platform for the ocean color, and we provide a product of chlorophyll, turbidity, and so on all over the European Sea. We are also certified in ISO 9001 in France. So the second SME is Acteon, and Gloria will present the activity of Acteon, please.
Good afternoon, everybody. Thanks, Philippe. Acteon is a French consultancy, and we bridge knowledge and policies by looking at collective answers to the challenges of ecological transitions. We work on several environmental domains, but in recent years, we've been working more and more on marine topics, which can be from business models for multi-use platforms or economic analysis of algae production, but also to ocean literacy. So we range from we work on a wide range of topics, and we work a lot supporting policymakers at different levels in France and Europe, as well as private companies. Thanks, Philippe.
Okay, thank you, Gloria. And the third one is Bantry Marine Research Station. Julie will present the
hi,
SME. Hi, Julie.
I'm Julie McGuire, and I am the research director here at the Bantry Marine Research Station. So we conduct marine research, obviously, but we also have commercial farms. So we have a finfish and shellfish and seaweed hatcheries. And on the seaweed side, we actually have 3 sites now. We got one the other day in 3 different bays. One of the sites is an IMTA site, and we're extremely busy at the moment because like October and November are when all our seeded strain goes to sea all over the country. So we supply everyone from the very north to the very south, and yeah, so that's us in a nutshell.
Okay, thank you, Julie. So now I will present the previous study that we have done during 2022. This study conducted by us was commissioned by the European Commission to support the European Green Deal. The general objective was first to produce digital raster maps of the production potential of shellfish and seaweed all over the European seas, and to help plan the marine aspect of the Green Deal. During this study, we have targeted 3 seaweed species: Saccharina latissima, Alaria, and Ulva, and 3 shellfish species: blue mussel, king scallop, and Pacific oyster. This production potential was estimated through numerical modeling on the basis of data from the Copernicus Marine Service. It was a requirement of CINER. As I say, input come from Copernicus Marine Service. It's mainly output of reanalysis model. For seaweed, we use the nutrients models, currents, temperature, phosphate, and PAR. PAR come from NASA Ocean Color, because PAR is not available in Copernicus catalog. For shellfish, we use chlorophyll A, currents, and temperature, and we developed seaweed growth numerical model and shellfish growth numerical model to produce outputs, mainly raster maps of production potential. Production results include fresh weight, dry weight, kilocalorie, and protein equivalent at different scale, per unit area, per length of line, per farm of given size. And we also study the environmental impact of this production on the CO2 uptake and the nutrient uptakes. So another part of this study is to evaluate the placement of farm for a target annual production. Here is an example for Alaria esculenta for optimal farming for a production of 10 million tons per year. Different criteria has been applied: maximal depth 30 meters, surface of each farm 1 kilometer, distance between farm 5 kilometers, and we obtained 2046 farm, mainly in the channel around the Britannic Islands and along the Portugal. In the left, we produce the distribution of the impact of the farm nutriment on the NO3. Here is a NO3 deficit after 1 season on growth of Saccharina latissima for a targeted production of 10 million ton fresh weight. So another study has been led by Actean, and it's about only about algae and climates. And I think that Gloria can explain or present this study.
Yes, the study was conducted in 2022 together with TNO, Aarhus University, and University of Copenhagen. And it was an analysis based on a comprehensive literature review, and the focus was on both macroalgae and microalgae with 10 species in total. And the objective was to assess the potential and the impact of I cannot see the PowerPoint.
Philippe,
Oh, sorry.
we see your screen.
So I tried to contact Martin for the next. Okay.
Yeah.
Sorry.
No problem.
Thank you.
So the objective was to assess the potential and also the expected impacts of scaling up algae cultivation in Europe. And in particular, we looked at the production potential in terms of biomass and proteins, the reduction of greenhouse gas emissions, but also to look at the underutilized production potential in Europe, and also to see how scaling up this production could contribute to European climate objectives. So key outputs, production potential in terms of proteins, the environmental impact, which is on the one hand greenhouse gases emissions and greenhouse gases retention, so the overall carbon footprint. And also we looked at production from an economic point of view, so in terms of production cost and also the added value of algae in animal feed and the broader economic impact of algae farming. Next slide, please. Thank you. Well, I don't have a nice role today because the outcomes of the study might curb some enthusiasms in the room, but we just collected the available evidence. So in terms of biomass and nutritional yield, microalgae production systems provide higher nutritional yield as compared to microalgae. When looking at greenhouse gases emission, closed systems have higher carbon dioxide fixation efficiency as compared to open systems. At the same time, the carbon footprint of algae was not fully comparable to soybean due to an incomplete input considerations in terms of fertilizers and irrigation. And then we come to production costs, which is where problems start arising, because algae production costs, both microalgae and macroalgae, are significantly higher than conventional feed. And even though cost data is scarce, algae is not yet competitive in terms of pricing. And overall, we saw that the high production cost and limited benefits mean that algae farms are not currently profitable. And also when looking at additional revenues coming from carbon credit sales. Overall, the maximum possible algae production in Europe could sequester from 5 to 21% of Europe's emissions based on ideal conditions. So this analysis ignores water or land limitations. At the same time, algae is not competitive as a feed source, especially for production costs and the prices that would have as a consequence. But also there is a problem of high concentrations of minerals like iodine, cadmium, and mercury that make it unsuitable for animal consumption. So these are the bad news coming out from the study, but of course the evidence base is still not so comprehensive at the moment. Thank you.
Thank you very much, Gloria. Okay, now I will present you the continuation of the project. It's a new project beginning in June, focused on the North Sea and Baltic, and more especially on future offshore wind farms and current offshore wind farm to introduce aquaculture in these fields. one of the new information is that we have to introduce a contaminant in the models of growth to quantify the impact of the viability for commercial use of the production in the farms. And other improvements, it's a new selection of species adapted on the area. We will develop new growth model for new species and replacement of refined numerical models, particularly from shellfish. In the right, it's the map of the wind farm status approved in construction, planned, or in production. So the biggest area are only planned for 2030, I think. So now Martin can explain the scientific models and what we will do during this project.
Thanks, Philippe.
Thanks.
Sorry, I was a bit late. Can everyone hear me okay?
Yeah, right.
Great. Sorry, I'm traveling today, so I'm just sitting in my car on my mobile phone, so I wasn't sure if this was going to work, but it did. All right. Yeah, so hi, I'm Martin Johnson. I work with Julie at Bantry Marine Research Station, and I'm a biogeochemist. I was involved in the previous study where we developed seaweed and shellfish models to apply and drive to be driven by the Copernicus data to do a kind of broad scale prediction of production potential and potential limits due to nutrient interactions of having a large number of farms placed in European waters. And I suppose an interesting point to note from that study, and we have a paper published on that, which maybe we could circulate to the group afterwards, where we find that at the scenario where we grow 10 megatons of seaweed in European waters, limited to 30 meters depth, so not placing any seaweed at greater than 30 meters depth. At 10 megatons of production, you're starting to see significant nutrient interactions inhibiting the growth of the seaweed in many of the farms. So that seems like a kind of a limit, a nutrient-based limit to productivity and therefore to CO2 drawdown. And we have those numbers in the paper, so that might be of interest. Also, important thing to say about CO2, just before I get on to the new study, which I think is a really important message that we need to make sure gets out there, is that the CO2 sequestration potential of the seaweed depends on what you do with the seaweed. I suppose that's kind of obvious, but if we eat the seaweed, the CO2 ends up back in the atmosphere. So if we want to use it for CO2 sequestration, we need to do something permanent with it, like burying it or biocharring it or something. Anyway, so this is rather science heavy. So I won't go through this in too much detail, but you see a schematic there of the farm model for the macroalgae. The macroalgal model is a simple kind of nutrient kinetics uptake based prognostic model based on the model of Hadley et al, parameterized for 3 different species. So as Philippe said, Alaria, Saccharina, and Ulva. In this project, we will extend the model to Fucus, which is of interest in the Baltic, and potentially to additional species if people are interested in them, and we can parameterize the model to represent those species. So it's not too difficult to add a new species and rerun the analysis. And then we will include a contaminant uptake model so that we can, in a simple way, relate the environmental concentrations of contaminants to potential contaminant concentration in the seaweed. I suppose it's worth saying, this contaminant model request, contaminant request is okay, Philip, you can go on to the next slide, was from the funder. They're very interested to know whether seaweed and shellfish grown in European waters are safe to eat. At the moment, we're in the process of compiling contaminant data to evaluate the likely concentrations so I suppose the first challenge is concentration in the water, and then the next challenge is how we represent that as contaminant in the end product. But I suppose it's not a problem that we necessarily recognize as being a significant concern in European waters relative to anywhere else. And even in the Baltic seaweed that's grown there, we know it tends to have below threshold values of contaminants. So it's maybe not a huge worry, but it's something that we have to deliver as part of this project. And so the shellfish model, we plan to re-engineer. The shellfish model we used in the previous study we found wasn't brilliantly fit for purpose, and so we brought in Brecht, Stekela, and Jonna Kotter, who are both experts in the dynamic energy budget modeling of shellfish growth. So we have their expertise and their models to implement in this new study. So we will look then at 2 mussel species and 2 oyster species, driven again by Copernicus data, but to predict growth potential and contaminant concentration. Probably next slide, Philippe. And just on the right here, we have a kind of summary of our proposed approach. So we have, in green, we have the growth models. So that's the input of the input data from Copernicus to drive seaweed and shellfish models. And within each model, we can change the species by changing the parameter sets. Will give us yield data and uptake of nutrients, which then feeds back through our hydrodynamic tracer model, which propagates the use of nutrients downstream. So without having to have interactive coupled biogeochemical models, circulation models, and aquaculture models, we can look at the impact through time of the farms on things like the nutrient deficit. So they're taking nutrients up, or seaweed is taking nutrients up from seawater. So downstream, you would expect there to be lower nutrients, and we can predict that and use that to model farm interactions. And at the same time, if you follow the orange path from the left, then we will be looking at compiling contaminant data, which is a job we've actually started doing already, and then looking for co-located proxy data on the basis that we don't have enough contaminant data for any particular species of contaminant to do a simple kind of interpolation to get concentration fields across European waters. We need to look for proxies to predict relationships to be able to get to what's the contaminant concentration likely to be in a particular place within European waters. So we will predict contaminant distributions, or at least that's our hope, and then using connections to our growth models, we will then look at uptake or adsorption onto the surface, in the case of seaweed, probably of some contaminants, to predict then the contaminant concentration in the biomass. So I suppose then on the left, what we know is that there definitely isn't sufficient data, as I already said, to make interpolated gridded concentration fields to drive our models. So what we hope to do, and what we think may be possible, is to use some kind of predictive relationships with proxies, such as salinity or nitrate, to be able to predict the concentration of contaminants where we don't have the data. But then I suppose we have a fallback plan, which is if there's insufficient data to do that, then we can do a kind of reverse modeling approach and say, well, what would be the threshold environmental concentrations that would lead to concern in a particular area, using our growth models. And so we'd look at, we could look at heavy metals, pesticides, persistent organic pollutions, polyaromatic hydrocarbons, other organics. You can see the list there. What we aren't going to look at is harmful algal bloom toxins, because they're transient events rather than persistent pollutants. So those are avoidable in terms of choosing harvest time, etc. And we won't look at microplastics due to a lack of data and, I suppose, understanding of their impacts on food safety. So that it's maybe a bit immature at the moment for us to look at. And we're working at the moment on choosing the contaminants to look at. So that depends both on their kind of importance and maybe how representative they are of a wider group of contaminants, because you know, we need to choose specific chemical species to look at, and we are limited by the availability of data. If there isn't enough data to make useful predictive relationships, then we wouldn't choose those species if there are ones that we could, that would have a better result. But the other important thing, and we'd welcome your input here, is the input from the stakeholder community on which contaminants are, you know, you think are most important for us to look at, because we will need to make some prioritization along the way.
Okay.
I think that's probably the last slide, please.
Yes. Okay. Thank you very much. I think it's after it's just a discussion, a point of discussion. If you want to join our stakeholder panel, please contact me, and you will be involved in the project during for some workshop to have your opinion of the evolution of the project and what and your feedback to know if the relevant seaweed and shellfish species we target are okay, and which contaminants are important to track for this species in this area. And if you have some data that will help us to make this project in a good way. Okay, thank you very much. I don't know if we were too long or no.
Philip, you were great, and thank you all the speakers for that. You have actually 5 more minutes, so we can have a discussion round, or you would like to ask us something else? Otherwise, I can open the panel for questions.
Yes, kind of. We have said all what we want to say, and if we can make a discussion about the project and what we have done and what we will do.
Great. I would like to ask, first of all, when are you? What is your timeline here for the future? Like when?
Yeah, the timeline.
Steps?
Yes, we will make a first draft of the contaminant model by the end of the year, and we will have a workshop with all the stakeholders at the end of the in summer, before the summer, to present the project and the result of all the stakeholders, and we have to construct a panel with different stakeholders in different kind of category, industrial, scientifics, farmers, and so on, in June, I think. And I think that the project will end it in October 2025. And after we have the same project on the Aegean and Adriatic Sea.
Okay. Okay. So there is a follow-up on that.
Yes. Yes.
Excellent. Wow. I'm thrilled with this presentation, with your results and what you're doing. I think you belong to the future, and this is so much needed. So we are very, very excited to hear all that. This is a huge endeavor. So any questions from the audience?
So
I have one question about the data that you're using, because it's really interesting and nice to see how the available data is actually being used in these kinds of tools. Do you have any general topics or themes of where there's data lacking?
Yes, Martin can answer.
Philippe, shall I answer that?
Yes.
Yeah, I think one thing that came out of the first project that we highlight in our paper is the challenges around riverine inputs. So you know, the operational data from Copernicus the Copernicus models, I mean, is one of the key drivers of productivity in shelf seas in those models is river inputs of nutrients. But we also know that those river inputs are poorly represented. They're actually, until recently, poorly documented as well. So they were part of the models that wasn't really very transparent. But something that really stands out in those studies is that the different models run for the different domains where they overlap. The river inputs are often wildly different. So we give an example of the west coast of Ireland, where productivity predicted in Bantry Bay by the NWES model and the IBI, Iberia, Biscay Island regional Copernicus models are quite different, because Bantry Bay has a river input in one model and doesn't in the other. And that's the case for all rivers ultimately, and many small rivers aren't in any of the models. So we want to be able to understand the productivity potential near shore, where we're likely to do most of our seaweed aquaculture, but we don't have good data at Copernicus scale on the riverine inputs. Now, that's not to say that we can't go to those places and measure nitrate when we need to know it, so that we can then predict our seaweed growth potential. But we currently don't have that in the operational models. And I suppose there's a huge deficit of observations of things like contaminants. The challenge with contaminants is that even if you choose one of those bullet points that I had of the different types of contaminants, within that there are hundreds of chemical species. You can't measure one and somehow then know the other. So we have a real paucity of data on contaminants. So if they're an issue, that we're not monitoring well. I think the physics and the biogeochemistry in the models is pretty good. People have put a lot of effort into developing and tuning those models. So I think we can rely on the models. It's the inputs and the observations that we're short on.
Thank you very much, Martin. So we have 2 more minutes. We have 51 people in the room, and I think that the presentation was excellent, and I'm sure many of the people here will contact you, us included, of course. Yeah, I think that if that is all right, we can move on. Otherwise, any last questions, please, to the speakers? I have a question. So also you mentioned that you're looking mainly in the Baltic and North Sea, right?
Right, for the actual project.
And then you're moving to the Adriatic Sea.
Yes, after, yes. The progression of the project will be done in Adriatic and Aegean Sea. But we had to select other species and to tune the models, I think, and we will involve other experts.
Great. I think we have a lot of projects in the Baltic Sea, especially looking at river flows, nutrients, and so on, because it's such a eutrophicated sea and there are so many rivers. Actually, I was hearing somewhere that there are more rivers, more water in the rivers of the Baltic Sea than in the Baltic Sea proper itself. I don't know if it's true or just an urban legend or so, but indeed, and for the Baltic Sea, it is very important to have such inflow of nutrients. But hopefully also HELCOM or other organizations can help here at a higher level. You have a lot of support also from us.
And during the first study, we have some problem for the Copernicus model in Baltic Sea. I think they are not very, very realistic. So it's difficult to work with such model and to use this data. And if you have some local models of nutrients, it will be welcome to compare.
Great. No, I think now you're not alone, and you have also the submariners here. So, and you with Jonekota and with Brian, you are quite well sorted now. Thank you very much for the talk. We are very much looking forward to follow up on that. amazing.
Thank
Okay,
you.
thanks. I would like to go now to the next speaker. Thank you very much, both speakers. Thank you very much, Martin, also. And from Action, also very, very interesting. We will follow up on this excellent work. So for now, I would like to move on to Sophie Koch. And we have here as next speaker on the biodiversity data in seaweed farms. Sophie, we are working with the CMARC. You're doing a PhD. You're finalizing now. And you have worked also on getting data from biodiversity firsthand with seaweeds. So I would like to hear more about what you have in mind here.
Yeah. Shall I share my screen?
Yes, please do that.
Okay. See, you let me know if it's in presenter mode properly. Oh. Do you see the full screen?
Yep.
Okay, now I don't see you anymore, or anything of the call, so just say something if there's something wrong. Also, I have constructions going on outside, so sometimes I don't hear my own words, so if the sound is an issue, I'll just move to the other room. But yeah, so this talk is about a biodiversity assessment that we did within a project called CMARC in the Faroe Islands, and I would like to just give you an outline of what we did there and what that has to do with data availability and data needs and how little data there is actually out there. And so I'll just talk to you in the very beginning about biodiversity and seaweed, but just very briefly, because this is known to most of you. And then how we collected our data, in which setting we did that, what was the study site, the experimental setup, and then also just coming like to the very first results that we have, and just which kind of research questions we are able to answer with that, leading then to the reflections of our lack of data. And yeah, I'll close with that. So just really one slide on the general ecosystem service of biodiversity within seaweed. And there's a lot of claims out there and also already first data out there that it is actually a habitat creation. It provides shelter for smaller animals, it provides food, and not only for small invertebrates, but also for all kinds of other animals like fish, even mammals or birds. And we firsthand in our data collection had to take, the holdfasts apart with all of these little invertebrates in there. So we saw a bunch of shrimps and shellfish and crabs and even lobsters. And so, yeah, we see it, it's there. And but now the big question is, what does that mean actually? What kind of impact it truly has on biodiversity? Because just assessing it, just counting it is one thing, but then putting it into context of the local fjord, what does this biodiversity that you find inside the farm means in the context of the outside of the farm? Is it maybe negative biodiversity, pathogens, or even invasive species? Is it positive because it really truly creates habitat and so on? There is still a lot of data missing to make these sorts of claims, even though first studies and first publications are out there that have quantified biodiversity in natural kelp and in seaweed farms. And real briefly on CMARC. So the objective is basically that we, in the project, are producing 12 new seaweed-based applications that will make it to the market, and all of the different assessments that will be around it, techno-economic and so on, and biologically and all of the different parts of it. And our work, where I'm part of, is work package 9, which is on the ecosystem services. So we quantified 3 ecosystem services, which is the nutrient uptake and biodiversity and carbon sequestration. And next steps will be to value this. And this is a whole nother level of discussion. But yeah, the presentation today is really then for the moment on this quantification of biodiversity. And yeah, the study site is the Faroe Islands, and the cultivation farm is ocean rainforest. And it's a unique site because it's in the middle of the North Atlantic and the middle of the Gulf Stream, which really means it has ideal conditions to grow seaweed. It has a very steady water temperature from 5 to 11 degrees. And everyone, around here, I think, knows that that also limits the fouling. And It also allows ocean rainforests to harvest several times a year. They just keep on, cutting it and then regrowing, cutting and regrowing, and they don't have to put the lines newly into the water. They just keep them there, which is very interesting as well for biodiversity, because, some people say, even if you create a habitat, what happens then if you take it out suddenly? And that also means maybe a biodiversity sink and all of these questions. So interestingly, we were able to study a site that keeps the structures in the water. And, you can imagine all of the shells, growing around, and the steadiness of the habitat, basically. Also, very interestingly, as you can see here in the picture, is still very near shore, but since it's in the middle of the Atlantic and in the middle of the Gulf Stream, it's considered exposed. So like offshore would be exposed. It has, huge storms coming through. It has currents, waves and everything, but it also means it has a lot of nutrients coming with a lot of currents, which allows them to grow three-dimensional. So basically they grow not only the horizontal long lines, but also vertically down into the water, 10-meter long lines, and which then basically makes a three-dimensional cultivation site. And in our experimental setup, we tried to collect data on 2 different seasons to be able to compare what biodiversity, how it develops within the season. So the middle of the first growing season towards the full peak of the second growing season in July. And then also we studied 2 different sites within the same fjord, but one you see here is the more exposed one. It's almost at the edge of the fjord, and the other one is further into the fjord. So what's the difference there? And then, as I said, they keep the lines in the water. So we have data on first-year lines that were just newly put in, second-year and third-year lines. And we took out these 10-meter long vertical lines, and we sampled on the middle and at the bottom of it. So we sampled at meters 7 and 4. So we have 2 different depths as well. And so that means we have a lot of manually sampled data, which is quantitative data. But then we also complemented that with eDNA. And we took eDNA from the biomass that we collected to verify, really, did we identify the right species? Did they find something else that, we in detail couldn't differentiate the one shrimp to the other shrimp? And then also we took eDNA from water. And that was really interesting because that usually is a complementary data to the manually sampled data. And the way we sampled the eDNA in the water is that we took samples in the very middle of the farm, of the cultivation unit, at the edge of the cultivation unit, further away, and then also of natural kelp in the same fjord and in another fjord. And that basically means we have eDNA data that gradually, that they gradually go away from the farm and shows us the gradual difference to inside and outside the farm. And just a few pictures on how we sampled manually, just to give you an idea of what it means to collect that data. So we have, basically developed this sort of net that goes in, and is obviously heavy because there's a metal ring, and goes in and pulls up a whole vertical line with, like, either in April less seaweed and in July full of seaweed, long seaweed, and picks it up on the boat. And there we take those 30-centimeter samples at 7 and at 4 meters. And then we take all of the seaweed apart. We have them in sample bags, obviously, bring them to the coast, take all of the little animals apart, identify them, count them, and then store them like this, which would then go to eDNA. But also, what you see here in the middle picture, we would rinse the whole net of the whole line so that we get an idea of all of the mobile species that are caught in the net. So this would be all of the fish. Obviously, a few of them swim away, but maybe there's also other species that we capture in the net of the whole range of the 10-meter vertical line. And the eDNA was also not without challenges. As you can see here, you're not supposed to break the water surface when you take water for eDNA. So we had to come up with some sort of inventions of how to get that water. So we didn't have any fancy tools. We just had a very brave young man that actually went down into the cold water and collected the water for us. And then the next steps are, lab work. But this is just to show this takes several weeks to extract the DNA and then to amplify it, to sequence it, and so on. So a huge data collection and data assessment process there. And yeah, our research questions, the two first research questions that we can answer with that data is somewhat straightforward. Is really, we will know what kind of biodiversity we will have in this cultivation unit, and then also because we will extrapolate the data on the samples that we have towards what's the whole mass of harvested seaweed and how many species and how many of those species do we have in there. So that's pretty straightforward. And yeah, this is how it's not supposed to say anything much, this graph to you, but it's just like this is how it would look like quantified. And we can see from the lobsters, we have very few versus the Gramarita, the little shrimps, we have a lot. And yeah, so it just is something that's, this is how some of the data looks like. Obviously, the assessment and the analysis will go further to make them statements on what that means in the bigger context. So same thing for this question of comparing the different seasons, you know, how the biodiversity changes in this cultivation unit in the seasons, the different years of lines in the water, and yeah, and also the different sites, the exposure versus the non-exposure, how does biodiversity change within there? Also, just very, very, very first data assessments here, but I was using, or I am using the software Primer 7. This is something that does multivariant data analysis. And instead of like an Excel graph, it gives you sort of data clouds. And with this, you can see where are the similarities or where are not similarities. And from there, you can make out what's the factor that makes the difference. So what I started doing is, for example, taking from the two different sides, just the third-year lines, the lines that are longest in the water. And I looked at the, you know, I threw it into the software and saw and try to see what it tells me. And here, just looking at the factor, the different site. So that means here you don't really see much. So in the exposed versus semi-exposed side of the same age of year lines in the water, it's sort of well mixed. Versus then if you use the factor month, so like the different seasons, April versus July, you see a whole different set where the similarities are grouped together. So you can see all of the April data is grouped together versus all of the July is grouped together. So that's something that can tell you, okay, maybe exposure isn't such a big difference for biodiversity development. Much more actually is the different season. And that makes a lot of sense if you think about it. You know, even the species, you know, they grow. Yeah, so this is how it looks like if we start assessing our data, and there's a lot more to come. But then let's look at the last question, because we did want to put this into the context, because all of this data so far just tells us within the cultivation unit. But what does it mean? Does it even mean anything? Is that like additional habitat created? Is it good for the whole environment? Is it negative for the whole environment? And for this, we really need to actually compare it to the outside ecosystem. And for that, there's a lot more data needed. And this is where a little bit of our weaknesses, I don't know if I should call it weaknesses of the data collection, but just it's impossible for one project to collect all of that data. So we have very few data from outside of the farm. So we only have the eDNA of the water from outside, but is that going to be enough to compare something? And it's not quantitative data. eDNA is not necessarily always the perfect tool to quantify something, rather qualitative. And just a little side note for eDNA, there's also the problem right now that whenever you collect data and you have a sequence and you want to compare it, or we want to identify what kind of DNA that is, you have to compare it to a database of sequences. But there's so many unknowns yet that sometimes it doesn't match. So you don't know what the species you have collected is in the end, because it didn't connect with any existing database. So this is growing daily, basically. But especially for seaweed, there's a lot of data still missing. And the other sort of lack in our data collection is that, you know, we couldn't catch too many fish. They were obviously swimming away when we come with this big boat. And there are other tools that you would need to collect fish, cameras, and so on. And we weren't able to do that right now in this project. There's just limited means available. So in a nutshell, there's a big data need if it comes to comparing our biodiversity that we assessed within the farm to the bigger context. What does it mean for this Faroe Islands coastal marine context? So that leads me to the last couple of slides, just the reflections that come out of it, which is basically we still don't know how to best quantify fish. We have a ton of ideas, and there's also other projects that test this and that tool, even with artificial intelligence, cameras are in there and so on. But in the end, we can't cut off the fjord and just count it and then say, okay, thanks to our farm, there's this amount of more fish. You can always just make an estimate on it or an assumption. And more knowledge is needed there. And then second question is the seaweed cultivation, the site that we have, is that really additional habitat? Yes, it is additional habitat, but is it going to lead to additional species, or are the species just going to move over and it's just like thinly spread species now instead of densely in the natural kelp? We don't really know. That actually would mean we need data to compare it to the natural kelp, and a lot of data. And it's immensely difficult also to say if that fish is here twice or is it just there once and just swimming across to make it really in simple terms. And also that question of when does a cultivation might even have a negative impact, of like invasive species, or the cultivation is too dense, so it actually isn't doing too much good to the species, or you take it then out with the harvest. So all of that needs a lot more data and really long-term studies as well. And if you look into trying to value biodiversity and you go into biodiversity credits, it's insane. It's like 10 to 20 years studies of really proving something, and in the marine context even more difficult, but particularly if you have an activity like seaweed cultivation going on. I think it's going to be off the table to have a biodiversity credit there. It's going to be a different way of valuing the biodiversity. But yeah, a huge data collection would be necessary to prove it to those standards. So in a nutshell, to finish my presentation, we really need more collaboration in research projects to come up with like a standardized monitoring or biodiversity assessment method that really says we have tested these things and said this is actually useful data. Because we could say now we have spent a lot of time and money on the data collection that we in CMARC did, but what it tells us is not so useful. And that is then, a pity to have wasted all of this money and time. Versus other project might have, learned that this one other technique is a lot cheaper and it provides you with the ideal information that you need. But there is no such standard yet out there. So that's a huge thing that I would think is necessary still to come up with. And obviously lots of collaboration, and just coming back to the same word, data is needed for that. And also our context now, if we had more open available data on what the biodiversity looks like on the Faroe Islands, in these fjords, or in general in kelp forests, we would be able to compare our data to that more efficiently and could actually say something about our hypothesis of saying this is true, this is not true, or this is an improvement or not an improvement. But you can take bits and pieces here and there, but to make a proper statement on it, there is still more data needed. Yeah. So let me just finish with this, and that's my thank you slides, and happy to answer any questions or to get in touch for any other collaborations around this topic. Should I stop sharing? Yeah.
Oh, very, very nice. Thank you so much, Sophie. So that's a mouthful of information here. So you're looking at new data development and also biodiversity, and also looking out for new monitoring standards and methodologies and so on. Very interesting. I have one question. I mean, that's a naive question, but I would like to know, we know that we are harvesting seaweed. We know that the farmers' business is to harvest seaweed because they make a profit for that. But what I would like to know, from your perspective, from the biodiversity improvements, what's the best time to harvest compared to what the entrepreneur would like to? If there is anything like that, like time or times, or between one line and 3 lines, what was your conclusions, observations, maybe, if you have something to say to us?
It's very difficult, because if I say now the best time would be then and then, is like the best time to harvest is when the seaweed wouldn't grow, something like this, and that doesn't make sense for a commercially active farm. But there are some techniques. For instance, if you want to be very, very cautious of biodiversity, for example, a company in Canada just has made it their promise that they keep 10% in the water just for all of the biodiversity to sort of just swim to, you know, like let's say they lost a little bit of their habitat due to harvest, then they go to the 10% that they leave standing here and there. Or, I mean, it's a very nice case of the ocean rainforest because they do leave the structure in. So everything that grows that's sessile on the holdfasts of the seaweed or on the ropes, that just stays in basically. And yeah, there's different techniques, but I can't say what's the best when is the best moment to cultivate in order to keep biodiversity at its maximum, because we're still in the middle of the assessment of the data, and also no commercially active farm would be able to actually like orientate their harvest sooner or later. It's gonna need to be about maximizing the benefit from the biomass that you take out from the seaweed biomass. But maybe there are these little, you know, best practices that, you know, can come out of like, you know, our hopefully follow-up project, where we could say, okay, if you leave 10%, that actually shows that 50% of biodiversity survives. And I'm just making broad claims here, but like these sorts of things could maybe be researched. Yeah, it's a vague answer, but I also don't know.
Thank you very, very much. No, that was nice. So we have break crops like we do in agriculture, for example.
Yeah.
In a way. You have 2 questions from the audience. Julie, please go ahead.
Hi, Sophie. I really enjoyed that now because I've been very interested in biodiversity and our seaweed farms because we have 3 sites here in Ireland, and one of them is an INTA site. And so I'd love to measure the biodiversity similar to what you've done. So the net, first of all, the mesh size of the net, do you mind me asking what size did you use?
Yeah, very, very good question. And also a thing that was important to us, mesh size was 1 centimeter. So basically by lifting it, we couldn't keep it smaller. The boat would have just toppled over. There's too much drag. So we had to make it 1 centimeter, with the huge lack of missing everything that's smaller than 1 centimeter. We cannot count it. I mean, we have it, obviously shrimps of, I don't know how small that we caught, but we can't quantify them because technically they're all washed out. So that was a huge thing, and we couldn't go around it. We can't, we would have had too much drag. We have to pull up, as I said, this was like 50 kilos of just a net and the seaweed plus the water. You can't pull it up. Yeah. Good question, though.
No, it's tricky. And I feel your pain as well with using cameras, because we put some cameras in and we have no idea if the same fish is swimming around and around and around. And, you know, whether there's 1 fish or 100 fish and it's the same fish. But anyway, yeah, thanks for that information, because we'd love to collaborate with you guys if you ever wanted to come over, and you know, we're happy to share, because our sites obviously are not like yours. We have to harvest in May is the absolute cutoff, because and incidentally, if you leave the seaweed longer into June, oh my God, the biodiversity goes crazy, because everything is trying to attack the seaweed and eat the seaweed, and you know, it's full of things. So, but you've no seaweed left. Okay. Okay. Thanks again.
I will reach out. Yeah, because we do have ideas for projects.
I'm time conscious now, Joel. If it is a very short question, please go ahead, because we are running actually a bit late to the next speaker.
Thank you.
Please.
Yeah, I will be really short. I would like to be in contact with you, Sophie, after this meeting, because we have this project BioBus that we are working with, looking into biodiversity credits for the multi-use concept.
Oh, nice.
In the Baltic Sea.
Okay.
So, yes.
I'll write my email in the chat.
Perfect. Thanks.
Thank you very much, Sophie. It was a brilliant and nice and inspiring presentation. Thank you very much for joining us once more, and we'll come back to you, of course. So, for now, I would like to move on. It was a very interesting. We had all these horizon discussions, cool breeze coming from the farming. Now we are going to a more operational knowledge space. So we have now Algae Propanos project. We will have Tariq and Stefania presenting about algae knowledge base and algae comics tool, data scarcity and uncertainty in algae domain. So it's more the operational side of the data part, and then we can go back to the ocean, I think. Please go ahead, Tariq.
Yeah, thank you very much. So I don't know if Stefania would like to start or me.
I don't mind, whatever you prefer, Tariq.
Yeah, please start, Stefania.
Okay, so I will start sharing the presentation then. 1 second. Okay. I hope you can see my presentation. Let's see if I can start from the beginning, in presentation mode. Okay, so yeah, thank you very much for having us in this working group. This presentation is mostly about the algae economist tool and the data scarcity in the uncertainty and uncertainty in the algae domain. Basically, as Talia was introducing it, this is part of the Algebra Banos, in which we are trying to develop new products, tool guidelines, and acceleration of seed for startup for different sector, and to demonstrate market accessibility and and presence of new algae product in the Baltic and North Sea. So the main within this set of tools, in which Tariq will introduce you more later on in his presentation, the algae economist goal is basically to have an economic screening tool for various algae valorization and product. Basically, just to have a screening tool for fast evaluation of different algae options, and it will be available for industry, startups, researchers, and investors to make their own combination of the algae type, processing technology, and target products, and give it helpful insight on the cost and the revenues of the selected valorization route, and a breakdown of the capex and the opex of the process. The concept is basically to build this tool around the current algae supply and characteristics and process technologies and different applications that you can do with algae biomass. Here, I just stated some kind of example of data sources and some kind of TNO project and know-how that we have built through the years. But of course, as you know, data is very scarce in this sector, and moreover, also, let's say, economics data. Just as an overview of algae valorization, as you can see, there are so many combinations and so many different types of processing, harvesting, logistics, and so many potential applications. And we have many options, many combinations, but there is very limited information about the economic parameters. The algae economist engine is basically consists of, let's say, having some kind of information of algae yield and processing step for building out a simplified process model, and then with that, get an information about equipment sizing and costing, and with other information about biomass prices, product prices, we arrive to total capital investment and key economic indicators, as for example, payout time, ROI, or minimum selling price. Here now I would like to give you a bit of, let's say, small tour of the prototype that we have been building together, TNO together with SDU, about this tool, and which basically consists of three main, let's say, calling databases of information, in which in the first one we have some kind of algae information about the algae species selected, and we have some kind of information about the processing steps and some kind of information about the product prices based on the targeted sector. As an example, you can see that for the algae information, you can get for the species, which kind of species it is, what is the protein content, the lipid and the carbohydrates, but it's just an example. There are more information available if needed. And then also, like, these are some kind of typical processes that we were considering, but we are still building on building this database of different processes, but as well, also to have some key market prices that we could retrieve of different kind of application of algae in, for example, in the hydrocolloids or the bioactive or pharmaceutical ingredients. And as you can see, for once the user selects the algae species, you can actually get a suggestion for the price. But since we know that there is very high uncertainty on that, then the user is still can be adapt this price based on the current information that he has, but as well also adjust the capex and the opex in case they have some innovation that they would like, some kind of innovation that reduce the capex that they would like to check with this tool. Moreover, there is also the possibility of changing the price suggested by the user based on their needs, because most of the time small startups are more conscious of what is their market price than others. And this tool at the moment is able, this is a kind of like some kind of example that I provided here about having, let's say, with a selected algae species, price and capacity and some key processing step and some kind of cascading approach, you can basically see what are the key economic indicators and also a bit of a split of the cost in a form of a waterfall diagram about the feed of biomass, the OPEX, and let's say the revenues of byproducts. So, but of course, this tool is just in development. This is very first prototype, and basically in the future, we will make this tool more interactive, and as well, we will try to add more processing step and updates about also the breakdown of the capital cost. So this tool aims just to accelerate the growth of the blue economy, and we hope to collate as many input as possible. If you have any feedback or idea, feel free to contact me or Tariq. And later on in the chat, I will drop out some Windows form in which you might make us aware of some kind of source that you think that it might be useful for our tools. And with that, I think that thank you for your attention, and I will give the word to Tariq, I think.
Much, Stefania. I will share my screen. Yeah. So now, can you see my screen or not yet? Yes, perfect. So now I'm going to talk about another work package, another task from the work package from the Algae Propanos project. It's about building the algae knowledge base. I mean, the main aim here is to support the specialized research needs by providing algae researchers with access to highly specialized information, enabling them to find relevant data and insights that go beyond general purpose language models like ChatGPT, and increase the accessibility for algae knowledge by making specialized algae knowledge widely accessible through an online platform, and improve the query precision and contextual relevance and reduce information overload. So we started our work, so we released the first prototype in April 2024 during the project meeting in Copenhagen. The main idea here was to collect a small data set to test our model. So we followed a simplified REG architecture. REG is abbreviation for Retrieval Augmented Generation model. We wanted to build a foundational proof of concept. So the data set was, as I said, limited with almost 800 research papers and book and almost 300 Wikipedia pages about algae and seaweed. So the primary goal was to assess the basic functionality of the tool and see how, if it works with a small data set. So during the meeting in Copenhagen, the domain experts who were there helped us to assess the performance of the model by evaluating the answers of the questions that I asked. Here, the main idea, it was like knowledge base connected with the user interface that can answer questions similar to the ChatGPT. And then the evaluation results from the first prototype, we built where we assessed the question according to answer correctness and question specificity. As you can see, most of the answers were incorrect, especially for the specific questions. So after the first round of evaluation, we get the feedback from the domain expert. We did the analysis of these errors and feedback, and then we tried to enhance the knowledge base and the retrieval system by using advanced techniques. So the second release was in October, like last month. We have used bigger data set with 5,798 research papers, reports, project deliverables, and books, and the same number of Wikipedia pages. We have used an advanced RAG architecture. So here we got the better performance and concrete answers, especially on domain-specific questions. So the answers for generic questions were less correct, and that's exactly what we wanted, like domain-specific knowledge base where it can answer domain-specific questions correctly. And here you can see like the architecture that we followed. I'm sorry if I am very technical in this presentation, but it's like really technical work package. So here, when the user asks a question or like generate a query, it goes firstly to a large language model, something similar to ChatGPT. It creates like 5 variations of the same question, and this is especially to avoid any errors generated by the user. Sometimes there are some errors in the question semantically or like syntactically, and with this process we generate 5 variations of the same question in a correct way. This can solve like the language barriers for the users. Then this 5 variation of the same question will go to the retriever, which will look for the answers in the knowledge database. Here, as you can see, this data vector database is where we save our knowledge base. So here we have data collection tool that collect all what we can collect from the internet, like all publicly available resources, books, research papers, reports, patents, whatever we can collect. And then we store them store the embeddings in a vector database. And here the retriever will get the answer for these 5 variations of the question, and then it will provide a context for the large language model to build the final answer. So here the main difference between our knowledge base and ChatGPT, for example, the ChatGPT will provide the answer from itself, but here we provide the context and the specific answers to ChatGPT or like to the large language model, and the work of the language model is just to provide the context or like provide to formulate the answer. And here each answer is connected with the original article or book or report where the answers can come from. As you can see, this is like the advanced architecture, the multi-query RAG system, and this is connected with the user interface, which is now unfortunately is not working. We are doing some maintenance on the back end, but the tool is available on algaebrain.tk. So I mean, the last few months we were working extensively on the pipeline. Now we have time to work on the interface. So now we are going to enhance like the performance on the interface. Here you can see the comparison between the performance between the first initial model and the ChatGPT and the new model that the second iteration of the model. Here you can see the first model, the answer correctness from scale between 0 and 1 was like 1.85. So 5 is a good answer and 1 is totally incorrect. And here like the correctness for the second model is like 3.71. As you can see, the increasing the size of the knowledge base and system architecture enhanced the correctness of the answers. And here you can see the performance between the first and the second model. Here you can see this is like the second model. Most of the answers are above 3. Here, like 1 was, as I said, very bad. 5 is very good. And as you can see, the more specific the question is, we get better answers. So here, for less or like for generic questions, we get like, for example, the average of 3. And for like specific, more specific questions, we get correct answer. And this is like the idea of the domain-specific knowledge base that can answer domain-specific questions. So now, as I said, the work is still in progress. We are still collecting data automatically and manually, and we need your help with that. Now we have more time to enhance the user interface and the user experience. So we are also working to analyze some feedback from the domain experts who are using the tool now to add more functionalities to the user interface, and then always adapting the state-of-the-art in the large architecture and language modeling. And at the end, I would like to ask for your help. If you have any data that could contribute to the Algae knowledge base, please share it with us or let us know where or how we can access it. And then you can always contact me on this email. Thank you very much for your listening. Thank you.
Thank you very much, Yusuf. Thank you very much, Tarek, sorry. And Stefania, that is really, really nice effort. When can we have a take in this tool or tools? You had the 2 tools you presented. Are they coming in the beta version anytime soon?
I mean, the Algae proponents was working in the morning, but now I don't know, it's not working. I mean, we still have some problems with the deployment. I mean, officially it's online and it's accessible. But as I said, we are hosting the tool now on small server to reduce the costs until we have like we release it like when finalize it, then we can host it on large server with advanced feature specification. Yeah. And for the economist tool, Stefan, you can answer.
Yeah, well, I was just, it's basically the same as your tool. Is basically, you know, in the server there will be both tools, and yeah, soon I will, we will basically. That's why I dropped the form in the chat. That soon I would like people to test it and see, you know, like. But that's why I put like for people if they're interested in testing, to put their email so we can contact them in case.
Okay, great. Thank you very much, both of you. That's great work, very useful for many of us, for companies and for scientists, for students. I mean, and we are very much looking forward to using it. And probably you will hear from us, from social media or from Submariner newsletter when this is actually released somehow, the tools. So thank you very much for your presentations and coming with us. Now I would like to go to the 4th speaker for today. Apologies, we are a bit late. We will try to close in at on time. I think we have 3 o'clock, but we will try to do our best in order to cover your all questions. And so we'll be able maybe 5 minutes late, but hopefully we will try to be close on time at 3 o'clock. And with that, I would like to go to the Mary. Hi, Mary. So you are industry relation partner for EMBRC, European Marine Biology Research Cluster. And we are delighted to have you here. And now we are talking about omics, not only about algae or mussels. I think we are talking about marine biotechnology, biodiversity topic. Are you here?
Yes, hello everybody. Thank you for your invitation.
Oh, lovely. Now I see you also on my screen. Yep, welcome. You're very welcome to share your slides if you can.
Okay. Wait, because I thought that you were going to do that, but let me just open them.
I have them
Okay.
too if you want to show them.
Maybe Maya can share.
Okay, share. Yes, if you can share maybe, because I can't. PowerPoint. No, I can't. Maya, do you have my slides? Normally I send them to you.
Yes, I have them. 1 second. Here.
Yes, those are the ones. Thank you very much. Okay, so thanks for the invitation. My name is Mary Piña. I'm the Industrial Liaison Officer of the European Marine Biological Resource Center. So if you can go to the next slide, you will see that what is the definition of our organization. So we are a research infrastructure. This means that we provide training, access to facilities, expertise within all our partners. So we have a legal status that's called ERIC, European Research Infrastructure Consortium. These allow us to provide, to give longevity to our initiatives. We are a long-term organization. We are funded by 10 member countries, which you see in this map. And our partners are the universities, research centers, and marine stations in these 10 countries. So in total, we have 81 marine sites. And the objective of building this research infrastructure and provide all this training and service and expertise is to advance the understanding of life in the oceans and sustainably harness its potential for humankind. So we partner, through our organization, we partner with different research projects, but we also, this long-term status that we have allow us to set up initiatives from our own, like the one that you will see in the next slide, which is called EMOBON, is the European Marine Omics Biodiversity Observation Network. So this is an initiative that we fund ourselves. This ensures that all the data that is recovered is long-term. What we do is we monitor biodiversity using eDNA techniques, and we do this along all the coastline from the Arctic Sea to the Red Sea. We have currently 10 participating countries and 20 partner institutes, and we do 3 types of sampling. We use water column metagenomics, soft and hard substrate metabarcoding, and we collect more than 50 physicochemical variables, including chlorophyll, nitrate, phosphate, turbidity, etc. This program is endorsed by the UN Decade, and we have a handbook with all the protocols that are used and that are standardized. So this ensures that we use the same protocols throughout all these 20 partner institutes. So in the next slide, I present you why we were motivated to create this observatory in Europe. So, as you know, marine observation is very mature, but more for physicochemical variables. But biology, marine biology is not at all that well followed or standardized. So most of the biological observation programs are short-term because they are based on projects. So there is not always the same procedures that are applied to the different observatories that there are. And there are still many questions like why this organism was there, or when, or etc. So we wanted to we also need to have these long-term windows in order to be able to predict the biodiversity occurrences, but also to assess the changes, the anthropogenic pressures, and also to assess events such as climate change. In the next slide, I present the challenge that we want to solve. That is, well, biodiversity has no borders. So we wanted to harmonize the monitoring procedures between different countries. We would have common and shared resources among all of them. And this will improve the comparability and the interoperability of the results. And everything will be done under fair practices. So all the data that will be produced by Emobon will be findable, accessible, interoperable, and reproducible. So the objectives is to create a best practice observatory model. If we can go to the next slide. We are sharing protocols that will link these different observatories. We will provide a baseline for genomic biodiversity data. We have these high data and metadata standards now. And also very important, my organization has been committed with ABS regulations. So so this ensures that all the national international regulations are respected in this program. We have the protocols, the data management plan, and all the data available through our website and also in public platforms. And finally, and as I will say in the last slide, this provides a framework for global collaboration. So we want to go beyond only Europe. In the next slide, you will see a little bit about how we work. So as I said, we cover 3 different habitats. We have mock communities for sequencing. We centralize all the sequencing and the DNA extraction. This is done at a national infrastructure that's called Genoscope, that is part of a European infrastructure that is called Elixir. I don't know if that rings a bell for you. And also we have high standard quality control and open data. We standardize the metadata using Darwin Core or MixS, and well, the ABS reporting that I already mentioned. And the data is being released regularly as citable data papers. In the next slide, you can see the protocols for the 3 different samples, and you will see the periodicity with which we are sampling. What kinds of community, like for example, the water column, it's the microbial community. In the soft substrates also, and in the hard substrates, we also have, this is very relevant, we have this passive sampling. We use artificial reef monitoring structures, which are called ARMS. This is long-term. It's we put this how do you say, device, and we leave it for a year, and then we collect all the sessile and motile organisms, a little bit like what Sophie is doing, more or less. And we do metabar coding of thickness and COI for soft substrates and hard substrates. I can give you a little bit of an overview of this artificial reef monitoring system in the next slide. So with all our EMBRC partners are already collecting data through these devices since 2018. The data is used basically for research, but also for environmental monitoring. And in total, we have 81 arms in 16 observatories in 12 countries in Europe. This is a little bit of what it is done. So we do, the methodology is eDNA. We can define the composition of the community, interspecific diversity, and ecological key species. And also we have we are applying also imaging to these devices, so we can have like size, the age and class and distribution, the abundance, the community composition, using the images that we are collecting. We have applied this kind of system with the arms and the imaging at several offshore wind farm sites, and we have already published this data. It's a service that we offer, but also we have been part in several projects, European projects with this kind of research. So finally, to give you a little bit of the bigger scope of all these omics network that I'm presenting today. So in the next slide, I'm presenting one of the European projects in which we participate, which is Marco Polo. And the idea is to build a framework for European coastal marine and freshwater biodiversity data streams. So we are aligning global standards. With this project, we partnership with international actors such as the Marine Bond, as Goose. We participate also in UN Ocean Decade programs such as Marine Life 2030, OBON, ODIS, etc. And what we are promoting is to enhance the collection and the coordination of biodiversity observation, to develop cost-effective and accurate observation technologies, test and advance new tools, technologies, and models. And in this sense, I will show you another project in which we are participating to develop these new technologies and libraries. Also, we want to empower European biodiversity data producers and users with these best practice guidelines that I showed you in one of my first slides. Finally, we want to implement the Goose and the EV concept, which maybe you have heard. And in the next slide, you will see this project in which we are focusing in the technologies that are associated to eDNA. So we want to standardize and harmonize the data formats, the metadata standards, and the ontologies across different eDNA repositories. So this will improve the data integration and the interoperability. We want to create a digital ecosystem for eDNA repositories and an integrated reference library, which currently there is a diversity of libraries, so it's difficult to understand which one to use. And finally, we want also to establish a unified and standardized approach to eDNA research. So this will ensure that the data is widely used for conservation, for policy, or for other activities like social or economics. We have through this project, we are also tackling international collaboration. We are linked to the International eDNA Standardization Task Force. We have colleagues from other continents as far as Australia or Japan. And last but not least, in the beginning of my presentation, I mentioned that our research infrastructure is promoting services, and I just want to do an invitation for you to use our services. And in the last slide, I present 3 opportunities that you will have to access our services. So you will see these 3 different projects, and to which you can apply to have funding to come and do your experiments using our facilities. So if we can go to my last slide, I just want to thank you for your time, and I'm happy to have some questions.
Thank you very much, Mary. That was indeed amazing to have you again. I think it's the second time we are hosting you in the working group. It's been a long, many years, actually. We are thrilled with what you do, and really hope that we wanted very much to connect you with the speakers, but also with the audience, because there is so many interesting and so many cross-cuttings between what you do and Sophie and Philippe that they presented already before, and even with Tariq and the work they're doing. So yeah, amazing. Thank you very much. Are there any questions burning from the audience for Mary? I think we all shaken, Mary, but thank you very much for the calls, and we definitely promote them as well. I'm very happy that we reconnected again in Copenhagen 2 months ago. So we will be in touch for sure.
Thank you, Talia.
Yeah. Yeah. Now, Maya, do you have your slides? So can I? Do you want to share my slides? What do you want, so we can move forward?
Yeah, but we have a little bit more time if anyone wants to ask questions to any of the speakers that we have. And
I would like
otherwise,
also to ask people to come with the cameras on so we can see them also, to see who is who, because we have 44 people. Hello. It's much more friendly, yeah? Good to see you.
because I would like to ask one question to Mary then. With the working with the open data and the standards and everything, I'm very amazed because I used to work with this a lot before, and it's difficult. So it's so good to hear that someone's carrying a big load there. But how is this all integrated into IMODNet? Because that's one of the bigger platforms that people usually work with, and I have not seen this data there.
Yes, so for the moment, so it's been 3 years that we've been running. We are starting to have the first results of the analysis, and this is already in the ENA. And after we publish, we will upload all the data to IMODNet. So it is foreseen.
Nice, perfect, good. Does anyone else have any questions for any of the speakers? Then I have a question for Sophie about the biodiversity data. Because as you mentioned, it's very difficult to know what is relevant at all to collect. But then there's also a really big difference between data and information. And when it comes to biodiversity, it's difficult because biodiversity itself is not really data collected, but you collect some other data and then you create information about what kind of biodiversity you have, or what the status is, or whatever it is that you want to kind of convey. How do you think that we can, because the two terms are often used interchangeably, so how do you think that we can overcome, and in the scientific community be better at actually communicating biodiversity information and what data we need to make this information?
Well, it's a very difficult question, very good question. And I don't have the perfect answer to it, but in another slide that wasn't here, but in a different presentation from last week, I had a slide on like, why are we collecting this data? What for? Like, what is this biodiversity assessment for? Are we trying to just prove that there is no negative impact or no harm done, or are we trying to get a value out of it, which we in our project have to do? So this would be a different data collection then, which provides us info for the question that we asked, and it's always going to be a different set of data that we then would need. But yeah, I had some sort of a similar question that I couldn't even formulate here that I would have asked Mary, in the sense of that always depends on the context, right? And that there is no, we're calling for a standardized way of assessing something, but then how can you make it standardized if the context in the question you would want to have this information for is different? Yeah, I'm not making a lot of sense because it's a good question I don't have the answer to, but that would be something that's worth picking up and discussing. Sorry, that's very vague, but I don't know. Yeah. Somebody else have an addition to this?
Yeah, so I think this is one of the big challenges that we are trying to tackle with this omics observatory, and we have a lot of discussions internally when we were setting up the protocols, like how would we need to sample, where, when, the protocols also for DNA extraction, etc. And well, at the end, that is why we wanted to harmonize like all our activities so they could be as comparable as possible. But as you mentioned, it depends a lot also in the question that you are asking, right?
Yeah, and it depends a lot also on the context geographically, because I know, for example, you asked the question before, is active in the Baltic Sea, and we heard about the Algae probanus. And biodiversity in the Baltic Sea is very, very different compared to the Atlantic, because we have about 5 species. So if you have 4 of them, then it's really, really good. So it's also difficult when someone says that that there is a high biodiversity. It's hard to know what that actually means. If no one has any other questions, I'm going to go to our last wrap up. I'm going to share.
Maya, one moment, because 2 minutes maybe. If someone has any news or announcements to share. Nothing, because this is our give and take. So it's a working group. So we would like to open up if you have something to share that is relevant to the Algae and Mussels working group or the data workshop, please go ahead. Or put it in the chat. You're very quiet.
I can just, I don't know if it's very relevant, but the data that we're collecting right now, the deliverable is due in February. So this is going to be, the next month is going to be really the assessment, and then first results are there in February. And I think then this is project internal probably for the moment, but we're going to publish on this. So then the next step would be a publication. And I see Joel nodding, so I will share that as soon as it's possible. And then as soon as the report, the deliverable are public, this is also to be shared, but nothing before February. There's a high intensity working, and then February, April, May, June, hopefully we get together a presentation where a publication out of this that's going to be open.
Super. Thank you, Sophie. Looking very much forward to that. Sabrina? Hi. I cannot hear you. I cannot hear you. Yep. No.
No.
I lost you again. No, unfortunately, we cannot hear you. Maybe you can put it in the chat. We can follow up on that. We'd be happy for this. Please do so. Okay? Maya, we can continue, maybe?
Continue. So yes, I'm just gonna end this session with doing some both some promotion of what's happening in some of the projects that we have at Submariner, but also some more information on the the next working meeting, but also where you can take the discussions further from this working meeting or working group meeting. So first, we already heard of it from the Algae Pro Bonos people, but there is a lot going on in many of our projects now, and we also heard from Mary on kind of opportunities for funding to take your ideas further, which I would love to follow up with you as well, so that we can promote it on our platforms. But right now, Algae Pro Bonos also have an application open for the Algae Accelerator. So this is a mentorship program, and you can apply to become a mentor or to become a mentee in Blue Biomatch. And what happens is that they're going to matchmake these applications, and the mentor can actually receive funding to have this 6-month mentorship program to the mentee. So it's really a win-win situation for everybody involved. So I'd really encourage all of you to go in and see what it's about, and maybe some of your expertise can be relevant. And similarly, one of our other projects, Baltic Muppets, has an open call that launched yesterday. And here you can receive up to 50,000 for SMEs to solve some of the challenges that the mussel farmers have identified within the project. So it's really a real-life application. You're going to get access to the mussel farms if you get one of the opportunities. What's important is that you have to be part of one of these regions. So it's the regions represented in the project. And the mussel farms are located in Sweden, in Germany, in Kiel, and also in Denmark. So for the hands-on challenges, then this is going to be your area. But you can read more on the website of both of these projects. And on the 28th of November, there's going to be an information webinar about this open call. And there's also an information webinar on both of these calls on the 20th of November. And you can find this in Blue Biomatch as well, so we can send out some links afterwards. Then we also have our third mission arena coming up. It's going to be in Amsterdam, 26th to 27th of November. And here we're going to see Sophie again. We're going to talk about a lot of interesting topics, but for this group, maybe the most interesting one is the LCA one. We've touched upon the topic before, so this is also going to be very standardization and the kind of data driven with all of the standards that we need to make good LCAs. So make sure that you sign up for the third mission arena if you can go. The regional focus is going to be North Sea. So it's not in the Baltic this time, but it's going to be more North Sea. So Netherlands, Belgium, Denmark, Germany, France, in kind of that way. And for the next working group meeting, we actually already have a date for this one, so you can all note it down in your calendar. You can also go to Blue Biomatch to register. It's going to be 30th of January, and the topic is going to be monitoring. Hopefully, the difference between data and monitoring is clear to many of you. If it's not, then I think you can think about the data more as the what, and the monitoring is how or when. So we're going to talk more about the methods of actually collecting data, how we should do this, and maybe even what is the data that we want to collect, and how do we do good monitoring for this. So that's going to be the next working group meeting. And I've been mentioning Blue Biomatch a lot. I hope you all know what it is. You signed up for this webinar using Blue Biomatch, so you're all a little bit familiar with it. I would really encourage all of you, if you're not there already, please join. So this working group, or these working groups, they're kind of hosted on Blue Biomatch, and these meetings are just a way for us to talk to each other in real time. but you can reach out to us and also to other people that are working in the blue bioeconomy sector. So all of these discussions that we've had today, if you have any questions or anything, I've created fora for this working group, so you can actually keep discussing if you have any project ideas connected to what we've talked about today. You can find them on Blue Biomatch, and you also have the Mussels working group and the Algae working group there. So just go ahead and pepper all of your questions in there so that we get some engagement and activity. It's always nice. And you find it here using the QR code, or you can register using the link. And if you have any questions about that, just feel free to contact me. And I think that was all for me. Talia, do you have anything to add?
I think we are sorted. We are delighted that you are here, and we are looking very much forward to see you again in the Arena 3 and also maybe in Athens for the final EU for Algae meeting. Take care, and we'll be back. Take care and continue the discussions on the Blue Biomatch.